Okay, in this video we're going to talk about polymorphism. Polymorphism is the ability of an object to perform the same action differently depending on the context. Let me explain you what I mean. Let's take a real-world example. Let's talk about a cat. Let's say a cat will run at a speed of 10 kilometers per hour. Now if a dog is chasing the cat, then it will run faster, maybe 15 kilometers per hour. So depending on the context, the cat is acting differently, but the behavior is same. Ultimately the cat is running, but the speed is varying depending on the context. That's exactly what polymorphism is. So in here, in the cat class, we have two methods. Both these methods perform the same action, which is running. But in this run method, the cat will run at 10 kilometers per hour. In this method, it's going to run at the speed whatever I send as a parameter. In our Java program, I've created an object of that class, cat. When I do cat object.run, it's going to call this method. When I do cat object.run, by sending a parameter, it's going to run this method. So what we have done is overloading, which we have seen in our previous example. The point I want to make here is ultimately the cat is doing the same job of running, but it is running differently. This is called compile time polymorphism. That's because during the compile time itself, the compiler will know which method to call. Although the name of the method is same, the signature is different. I mean, either the number of parameters or the type of parameter is different, just as we looked at in our example earlier. Now let's talk about runtime polymorphism. Just as we took real-world example for compile time polymorphism, let's take a real-world example for runtime polymorphism. Let's think of an animal. Every animal screams, but the way the scream will happen is dependent on the animal itself. Take a look at this example. In this animal class, we have this method screaming. But if you see, a dog will scream like a dog. So we have a scream method in the dog class, and it's going to scream like a dog. The thing here to understand is we have the exact same signature as to that of the scream method in animal class. What we did here is overloading, where we have two methods with the same name but different signature, and Java will not let us write two methods in the same class with the same signature. But it's possible in overriding, because in this class, this is the only scream method with this same signature. Now let's understand what is runtime polymorphism. In this class, we have an animal object, and using that object, I'm going to call the scream method. This instruction will call the scream method inside the animal class. But whereas if we have animal reference type, and if it points to a dog object, then this instruction will result in calling this scream method. So depending on the type of animal, the scream method will act differently. Ultimately, it's just screaming. Now again, if we have, let's say, a cat class, then we can have the same exact method. Scream like a cat. Now let's copy this code, paste it over here, cat and cat. Now this scream method is going to call the scream method of cat. Hope it makes sense. In order to make sure that the method that you wanted to override is indeed overridden, you're going to use the annotation called @O overwrite. This annotation will make sure that this method, the method that is next to it, is overridden. If you make changes to this method, for example, give it a different name, it's going to throw us an error. Or if you add another parameter, it's going to throw us an error. Let's see what the error says. The method scream int of type dog must override or implement a subtype method. We're going to override, but what is implement? We'll know about implement keyword when we talk about interfaces. But for now, let's undo the changes. Let's keep this annotation, it's a good practice, and I always encourage you to do the same. So the point I want to make here is, depending on the type of object to which this reference type is pointing to, it's going to act differently. Ultimately, all these objects are animals, but an animal can be a dog, an animal can be a cat, and depending on the type of animal, we want to trigger its respective behavior. Hope that makes sense. This is called runtime polymorphism. That's because during the compile time, compiler cannot make out which scream method to call. Should it be the scream method inside the animal class, or should it be the scream method inside the dog class? It just can't make out. So the JVM would be able to do that. It's going to override the method inside the animal class, and depending on the object it is pointing to, or we call it the true object. So this scream method will call the method inside that true object. Now where is the typecasting here? Java has done that for us. What has happened in this line is widening. Every dog can be an animal, so it's widening. But in case if you wanted to utilize the methods inside the dog, then you can always do explicit typecasting of this animal to dog. For example, you can have a statement that says something like this: dog D equals, just copy and paste it over here. The auto suggestion will actually fix the problem. It will automatically convert this object to dog. It will suggest us to convert this object to dog. And now you can always call attain the behavior of dog on the D object, d.bark. It's valid. But whereas if you're trying to do the same with any object whose true object is animal, then this would yield a compile time error. For example, you can't do this. It will result in compile time error, class cast exception. Let's undo those changes. Another point which I want to point out is this will actually make our life a little easier. Let's say we have a method that's just going to print the details of that animal, let's say. So print details static. This has to be static. The reason is this is a static method and we can only call another static method, and inside this we have something that does something. This is not going to return anything, and the parameter that we send is animal A. This way this method can accept literally any animal. And let's say we have 100 different types of animals like dog, cat, crocodile, elephant, etc., and they all inherit the behavior or extend the animal class. So we don't have to write 100 different methods for each and every object. We don't have to have the same method written for dog and the same method written for cat, etc. Instead, we can just send the parent class object by doing it in this manner. If you want to send dog, you can just have a reference type as animal, but point to a dog object and send this as a parameter to this method. And inside this method, we do narrowing, a valid narrowing that doesn't result in class cast exception, and we do anything that we wanted to do inside this method. Hope that makes sense. See you in my next video.